Point 4 is on complex numbers, and we need to review a little bit with complex numbers before we go on to quadratic functions. So remember that the basic building block of a complex number, we've got the imaginary unit, and the imaginary unit, I, equals the square root of -1. So you want to keep that in mind, and when we often will find this useful, or what we'll often make use of, is if I equals the square root of -1, then I squared equals -1. So these come up frequently with quadratics because if we take the square root of a negative, we end up with an imaginary number. Now a complex number is generally in the format of a plus bi, where a is the real number part and the bi is the imaginary part. So if you're putting it in its general format, you would put it into this form. So let's do a few examples to kind of review. If you are either adding or subtracting, you just combine like terms. So I'm doing a subtraction problem because I want to make sure you distribute the negative sign correctly. So we don't even need the parentheses here, -5 plus 3i. We're going to distribute this minus sign. So we end up with a -6 plus I. And now you're just combining like terms. So -5 plus -6 is -11 plus 4i. And this would be the format I'd want to leave it in because notice the format a plus bi. So the -11 is the real part. This 4i is the imaginary part. When you are multiplying, it's your option. You can FOIL or you can put it in a box. So if you FOIL, we're going to multiply the first, the outside, the inside, and the last. So we're going to have a +2. The outside, we're going to get -3i. The inside, we're going to get -4i. And then the last, we're going to get 6i squared. Now, keep in mind, every time you see an I squared, you're going to think that's -1. So this becomes 2. I'm going to combine these. I get -7i. And where did I lose my sign here? This was a plus. So we're going to have a 6 times a -1, so that's going to change this to a -6. So we end up with -4 minus 7i, and that would be my answer. Now this you can think of as division, or you can just think of it as simplifying the fraction. Now to be in simplest form, we can't leave an imaginary unit in the denominator, because keep in mind what that means. Remember, we couldn't leave a square root in the denominator either. So what we're going to do is we're going to multiply by the conjugate. And I believe we did these last year in Algebra 2. The conjugate, you find that by just changing this middle sign. So instead of a 2 minus I, it's going to be 2 plus I. Whatever you do to the denominator, you do to the numerator, because remember, that's like multiplying by 1. So what's going to happen is when you multiply these terms out in the denominator, you're going to, the I is going to end up going away, because keep in mind that this is like having the difference of 2 squares. Let me show you if we multiply this out. I'll do this one in a box. If we have 2 plus I times 2 minus I, we get 4, and a +2i, and a -2i, and then an I times a -I is -I squared. But remember, I squared is -1, so this actually becomes a +1. So these cancel out, and I'm going to have a 5 in the denominator. So that's what we'll end up with, and now we no longer have an imaginary term in the denominator. So we have to finish this off, though. We have to multiply the numerator, and so you're going to multiply that. You can FOIL it, put it in a box. So we're going to get 6. The outside gives me +3i. The inside is +8i, and the last is +4i squared. This is going to be in -4 because the I squared is -1. So I'm going to have 6 minus 4 is 2 plus 11i all over 5. Now, that's fine to have your answer like that, but remember that this is the preferred format of an answer when you have complex numbers. So I'm going to split this apart and have 2/5 plus 11/5 I, and now it's in that format. Okay, what if you are asked to simplify I raised to the 223rd power? Well, you're probably going to want to recall what this pattern was. Remember that I is the square root of -1. And we just are going to call that I. If we have I squared, we get -1. If we have I cubed, we can think of that as I squared times I, which would be -1 times I, or just -I. And actually, I'm just going to leave this as an I. And I to the 4th, you can think of as I squared times I squared, which is -1 times -1, which is 1. I to the 5th, we can think of as I to the 4th times I, which is 1 times I, which is I. And what's going to happen is then you're going to circle back through, so you have a repeating pattern. You're going to have I, -1, -I, and then 1. And then it's going to go back. So every 4th value, so I to the 1st, I to the 2nd, I to the 3rd, I to the 4th. Then I to the 5th is going to be back here, I to the 6th, I to the 7th, I to the 8th. And so you'll have that repeating pattern. So really what we need to know is how many 4s are in here. So shortcut, and we did this last year in Algebra 2, you can divide this by 4. And we don't really care about the fact that the 55, because that doesn't matter. What we really care about is the remainder. I get a remainder of 3, so then I count 1, 2, 3. So this is equivalent to -I. So that's how you would evaluate a problem of that type. Well, this one looks different, and we didn't do anything like this in the past, but you know how to deal with fractions. And so in order to simplify this, first of all, we can't leave the anything with the imaginary unit in the denominator, but let's first find a common denominator and combine this. So I'm going to use I to the 8th as a common denominator. So this fraction, I'm going to multiply by I cubed over I cubed. Because remember, when I multiply, and the bases are the same, I add the exponents. So I'm going to get I cubed minus 1 over I to the 8th. So now I can simplify I cubed. If you look back at that previous list, you're going to see that this is just -I minus 1. And I to the 8th power, that's going to just end up being 1. So my answer, I'm going to put the real number part first, is -1 minus I. Another example, if y equals x cubed plus 2x squared minus x plus 1, evaluate y given that x equals 3i. So I'm just going to substitute. So I'm going to get y equals 3i quantity cubed plus 2 times 3i quantity squared minus 3i plus 1. Don't forget, you have to cube the 3 also, so this gives me 27i cubed. I have to square the 3, which gives me 9, times the 2 is 18, so I get 18i squared minus 3i plus 1. So now I can make some substitutions, because remember that I squared is -1 and I cubed is -I. So I'm going to have -27i. This is going to be a -1, so that makes this a minus 18 minus 3i plus 1. So I have a -17 minus 30i. And that would be my answer. And the last one, same kind of setup. Now we're told that x equals 2 minus 3i. So this one would be a little trickier. It's x, it's that quantity squared. And here we have 2 minus 3i minus 3. So this right here, you're going to either have to multiply it out, FOIL it, put it in a box. I'm going to leave the 2 there. So if you want, if off to the side, if it helps you to see it, because that's what it means, you can FOIL that. We're going to get 4. Outside is minus 6i, the inside is minus 6i, so that's going to be minus 12i. And then we have plus 9i squared. Then we'll have a plus 2 minus 3i minus 3. Next, I'm going to go ahead and distribute this 2. So we have 8 minus 24i plus 18i squared plus 2 minus 3i minus 3. This I squared is negative 1, so that's going to make this a minus 18. So now I have 8 minus 18 gives me negative 10, plus 2, negative 8, minus 3 is negative 11. And I had a negative 24i minus 3i, so I get negative 27i. There is my answer. So that's it for our little quick review of complex numbers. You can get started on your assignment.